Yeah, good evening everyone. So today we are going to start our week 12 assignment, and this assignment is the last assignment for this course. So once again, I'm Ravi Kumar from IIT Bombay. I'm a research scholar at IIT Bombay under PMRF scheme. So this is the course of Physics of Renewable Energy Systems taken by Professor Amrish Chandra from IIT Kharagpur. So let's start with our assignment. So this is the first question, which says porosity of nanoparticles can be represented by. So you just need to tell me the formula for the porosity of nanoparticles. These are the options. Option A says total volume minus pore volume divided by total volume. Second says pore volume divided by total volume minus pore volume. Third says pore volume divided by total volume. And the last option says pore volume divided by pore size. So among these, which one represent the porosity of nanoparticles? A, B, C or D? So porosity is defined by this pore volume divided by total volume into 100. So option C is the correct answer here. From the lectures, this is a snap from the lecture only. You can see porosity is defined as pore volume divided by total volume into 100. So it is, this 100 is for changing it into percentage. So for this question, option C is the correct answer. So let's move to the next question, which says consider the following equivalent RC circuit and choose the Nyquist curve for this circuit. So here there are two resistance R1, R2 and one capacitance. So this R2 is in parallel with this capacitor, while both are in series with this resistance R1. So which curve is represented? Yeah, this question you need to solve by Nyquist curve. So here you can see this is the same circuit with two resistance, in which one resistance is in parallel with capacitor while both are in series with the resistance. So this is represented by this curve. So among these options we have option A. So option A is correct answer here. Fine. Okay, let's move to the next question, which says for BET surface area measurement, the minimum weight of the sample required to be transferred into the quartz cell is. So you just need to tell me the minimum quantity of sample which is needed for this BET surface area measurement or BET analysis. Option says less than 20 milligram, 20 to 30 milligram, 50 to 100 milligram or more than 100 milligram. So from lecture only, here we can see the weighing of approximately 20 to 30 milligram of the sample and transferring into a quartz cell. So here we can see it is 20 to 30 milligram. So yes, option B is the correct here. So yeah, for this question option B is the correct answer. Fine. So minimum quantity should be 20 to 30 milligram for this BET analysis. Next question says zeta potential measurement helps to determine the following property of a colloidal solution. And these are the options. You just need to choose the property which can be determined using the zeta potential measurement. Is it viscosity? Is it specific capacitance, particle size of the dispersed particle, or stability? Among these, which one can be determined using this zeta potential measurement? For this question, you can refer to this curve here, the effect of pH on zeta potential. We can see it is going from unstable condition to stable, both side. So yes, stability is the measurement which can be done with the help of zeta potential. So here option D is the correct answer. Let's move to the next question, which says the intensity of secondary electron depends upon. It is not asking about the energy, it is asking about the intensity of secondary electron, and these are the options. Intensity is directly related to the number of electrons. So if surface area is more, then number of electrons will be more, right? So option A, size of the irradiated object. Yes, option A is correct. Second says number of electrons ejected. Absolutely right, because this number of electrons are directly proportional to the intensity, because number of electrons per unit area is known as intensity. So yes, option B is also correct. Option C says chemical composition of the irradiated object. Why? Because chemical composition will decide how many electrons are there which are free to move or which can be ejected. So yes, chemical composition of the irradiated object is also correct. And fourth says energy of backscattered electron. It is saying energy. So its energy will change the kinetic energy of secondary electron, but not the intensity. So option D is not right. So explanation here also given the same thing. Yes, A, B and C are the correct options or the answer for this question. Okay, let's move to the next question, which says consider the following curve. If you haven't watched the lecture, so I just want to tell you, so this curve is related to BET analysis, and there are 6 categories. You just need to tell me this curve belongs to which type, and these are the options: type 2, type 3, type 4, type 5. Here you can see these are the types, 6 different types of isotherms, and this one resemble with this fifth one, type 5. Yes. So type 5 is the correct answer for this question. Option D is the right answer. Let's move to the next question, which says the relation between hydrodynamic radius, which is represented as dH, of a particle and the viscosity eta of the liquid can be expressed as. So here it is asking the relation between hydrodynamic radius and the viscosity, and these are the options. This hydrodynamic radius is directly proportional to viscosity, inversely proportional to viscosity, or directly under square root of viscosity, or inversely square root of viscosity. So for this question we just need to see the formula which is known as Stokes-Einstein equation. So from this Stokes-Einstein equation we can see this hydrodynamic radius is inversely proportional to eta, and here eta is the viscosity. So this dH will be inversely proportional to 1 by eta, and among these options option B is correct, not A, C or D. So option B is the correct answer here. So let's move to the next question, which says zeta potential of a particle depends on. These are the options. This zeta potential of particle depends on. Does it depend on pH of solution, measurement time, temperature, or gives free energy? So from the last question on zeta potential we have seen it depends on pH, right? Does it depend on measurement time? No, it should not. Does it depend on temperature of solution? Yes. Does it depend on Gibbs free energy? No. Here also you can see the factors affecting zeta potential are pH of solution, concentration of ions in the solution, conductivity of the solution, temperature of the solution, or fundamental surface size. So among these, this pH and temperature are in options. So option A and option C are the correct answer here. So for this question, A and C. Okay, let's move to the next question, which is related to the match the following. So there are different kind of porous, like that is macroporous, mesoporous, microporous, and ultramicroporous. You just need to match them with their size of pore. So this macropore, mesopore, micropore, and ultramicropore. So in this question you can do it easily, like macro means largest. So among these, which one is the largest? It is 15 nanometer. So A goes to third. Second is mesoporous, and then micro and ultra micro. Then ultra micro should be least one. So least is 0.7 nanometer. And then meso should be less than this 50. Yes. So meso will goes to 1, and this microporous will goes to 4, means less than 2 nanometer. And you can verify here, macroporous more than 50 nanometer, right? So 1 goes to third. Mesoporous 2 to 50 nanometer, mesoporous, yes. So B goes to 1. Microporous less than 2 nanometer, so C goes to 4. And ultra microporous below 0.7 nanometer, then D goes to 2. So A goes to 3, B goes to 1, C goes to 4, and D goes to 2. Yes. This is the answer for this question. So let's move to the next question, which is a numerical. So here we can see the maximum kinetic energy of electron ejected from a certain material if the material work function is 2.3 electron volt. So here this work function is given, phi is given 2.3 electron volt, and frequency of incident radiation, this nu is given 3 into 10 raised to power 15 hertz. And binding energy, let's take binding energy 0. Now you just need to calculate the maximum kinetic energy of electrons ejected from this material. Option says 10 electron volt, 20 electron volt, 15 or 5. Here you can see the formula for this photoelectron. This kinetic energy will be equal to h nu minus binding energy minus work function. So here binding energy is 0. So we can write kinetic energy equals to h nu minus work function. So just need to put these values for this kinetic energy. K equals to h, value of h should be 6.626 into 10 raised to the power minus 34. Just convert it into electron volt. 1.6 into 10 raised to the power minus 19 electron volt second into this nu is given 3 into 10 raised to the power 15 hertz minus 2.3 electron volt. So you just need to solve this. Just calculate it. You will get around 10 point something electron volt. Yeah, it is 10.12 electron volt. 10.12 electron volt. So among these questions, 10 electron volt will be the answer here from the options given. Accurately it is 10.12, but based on the options we can say it is 10 approximately. So answer for this question will be A. Yeah, so this is the last question. So we have done with this assignment, and this was the last assignment for this course. You can watch this tutorial again on YouTube, and if you have any question you can ask in comment there. Yeah, thank you.